I don't know. Our band saws it when I was in high school. Horizontal.
No, so we have a basement that's like not a crawl space, but
It's in there.
and of course they used to have a light
Sure was
on the second floor. That got
It was my gloves.
and then also
I know.
My nose was in space.
And the other Wisdom Cannon was doing something else. Was it Ari?
I didn't ask him, but he was kind of scared of me. I had to like ask him because we had like a soft spot for my favorite. And I asked him, like, "Can we take your straps off?" Because they were things that were like slowly vibrating.
Well, no, we figured it out. We got it.
All right, cool. We're back. It's Friday afternoon, the best time to do engineering. We're here. Last time we started looking at this car jack system. There's a lot of stuff to do, like as we're thinking about designing it and breaking up the dynamics for it. But first step was just recognizing like what is the geometry of motion. So just in this thing we have kind of, let's see, 1, 2, 3, 4, 5, 6 different moving parts that are all interacting with each other. But as we were talking about it, we figured out on Wednesday, it's really only 1 degree of freedom. Like if we know how tall the jack is, we know all the angles, we know how wide it is, like everything's kind of fixed based on 1 measurement. That's really useful for engineering things like this because you only need 1 motor, in this case a human arm, to drive the system. So there's a lot of like 1 degree of freedom systems with lots of moving parts like this. So on the right track. Great thing that we came up with last time was a relation between what the angles are, how wide this jack is, and how tall the jack is. So we had this connection between angle, height, and width. That was really important. That was probably the most important thing that we kind of settled on Wednesday. So I wanted to like come here, look at this star, the star equation, and see, do we agree with it? Like, is there any like discussion about how we got there? What do we think so far? Oh, polar versus Cartesian, yep. Here, this one, we're kind of doing, at least so far, we've only talked about like Cartesian coordinates, just X, Y, things fitting into a box. Yeah, I'm just pausing for like either catch up or clarification so far.
So,
Yeah.
so what we're doing is, are we trying to find like the velocity of B in the y direction, right?
Yep.
Okay. So would it be possible to take derivatives of H and D individually to get velocity?
Yeah. Yeah, so what we have here, like if you, for anything in dynamics, when you're talking about kinematics, the definition that velocity is the derivative of displacement. That's always true no matter what constraints you have on the system. So when we have functions like this, where we say like h is 2L cosine theta, the derivative of h is still going to describe the velocity, like how fast that height is moving. That's a great point to make. Cool. So where I wanted to start here, since we kind of know like geometry of this thing, like how tall it is, how wide it is, I wanted to ask this question. In here, let me give it a different color. What are the vectors that describe hinge A and hinge B? Where are those things? Oh, and we kind of did that, right? All right, nice. We did that. So then, is there an I component for this H? That one's just like 0I. So we know magnitude and direction. Cool. All right, so then we made it further. 2L cosine theta J. What about ER? It's okay to mix and match unit vectors, but at some point you got to get them all into the same system. So we can either convert J into ER and E theta, or we can convert ER into I and J. Which one do you prefer? Have you done either? Remapping onto one onto the other? Do you know what I mean by this? Yeah? Some yes. It's okay. The answer should be no. It's like, no, we've never seen this. We've never had to deal with this. And that's why you're here, learning this. Yeah?
What does E mean? E hat?
What is E hat? E hat, in this case, and I feel like we need different colors. So with those hats, they're always describing unit vectors where magnitude is 1 and then the direction can be anything that we decide. So in the case of like J hat is vertical. It's only a unit 1 vector pointing straight up. And no matter where you are, a J hat just describes pointing straight up. ER is choosing like from that angle theta. If theta is 0, it is J. And if it's 90, then it is I. So it's always pointing along that theta direction. That's our ER vector. Yeah.
The vector for B be the exact same, just its radius, because the radius unit vector, because one thing changing radius, it doesn't change, it's vertical.
Yep.
It's 0, so you just have to change the unit vector, nothing else?
So in this case, when we're talking that's okay. This ER vector, it changes depending on what point you're looking at.
Wait, for A. For B, I'm saying
Yeah.
you just change J hat into the unit vector for radius.
Yeah. Then it would be like an ER prime, where ER prime is always J hat. Like it's not the same ER because it's a unit. The ER and E theta unit vectors, they change direction depending on what you're pointing at.
But then wouldn't A be wouldn't A be a theta, so it'd be theta, not ER?
A theta.
So radius is this constant L with the,
Yep.
oh, no. Okay.
Okay. Yeah.
I was mistaken.
No, it's hard to think about, like, whenever you start mixing and matching unit vectors. Again, you can, but it just helps to, like, get them into one thing. At least if we're trying to think, because one of the things that we want to know is, like, if A is moving to the left at a speed, how fast is B moving up? What if we just forgot about ER for now? Not to say that we can't use it, but what if we just scrapped it and went back to the triangles that we have drawn here and try to define what are the opposite adjacent parts of that triangle for our X and Y coordinates? We could try that, right? We know magnitude, like, if we square them and add them together, it's got to be L squared. But what if we just went back to, like, there's some I and there's some J? What do we think those I and J's would be?
H and D.
H and D.
H over 2.
H over 2 and D, yep. And then that one's like H over 2, right? And we already figured out what H and D are. Like, we know those in terms of, like, the angle. Too many S's. Like that. You know what we just did? We solved for ER. ER is sine theta I plus cosine theta J. What? Because we can factor out that L. The L is the magnitude. Now the unit vector is a sine and a cosine. Ta-da. Oh, it comes around the full circle. All right, so then we can get to the fun part. What is VA and what is VB? Yeah.
I have a question about VB. So you can just use the tangent relationship between the velocities, but would the elevation change of this be 2 times the tangent theta? Because, or is that what I'm trying to say is VB would be like VA divided by tangent theta, but that's only for one triangle. So it's like this one's changing at a rate of VB, and so is the bottom one. So would the total velocity be 2 VB?
Total is 2 VB. So VB equals 2 VB?
So what I kind of did was I declared the bottom of the triangle. Like if we look at the top triangle,
Yeah.
I said VA was the bottom, was the base, and then VB was the side.
Oh, I see, like this.
Yeah. But that only counts for one triangle. So if you wanted to calculate the velocity change of the entire of the top, would you need twice the VB? Because technically there's 2 triangles, both
Yeah.
for the VB, but going in the opposite direction.
I guess it would depend, because we have a constraint that the bottom VB has to be 0.
Yeah.
So
So then it would
I think it would be, I think too, based on how you're describing it, I would think it's double whatever you had calculated it, if you're kind of using it that way. But we have these definitions for like length and angle. So everything is based on theta in this case. So if we know the angle, then we know where everything is. So there should be something about, if I know how fast the angle is changing, I should know how fast everything's moving. And that's the thought process that I have here. So my kind of coordinate that I care about, my generalized, it's called generalized coordinate. Like the thing that defines my system is my angle. If I know what angle it is and how fast it's changing, I know where everything is and how fast all those parts are moving. It's kind of, so what is VA and VB in terms of like theta and theta dot? Since we have these these are constraint equations, like hinge A and hinge B have to move in this way. What do we think? Do you know what I'm asking so far? Like how to get there? Okay. You want to try it? And we'll see what we get. Try it out. And I'll check in, see what questions there are. There should be questions. This is hard work.
We're not.
Okay, if you take the equation for the position of the particle, you can change the perspective time. Is there any time term that you can differentiate with? Or you take a time.
Then it's supposed to be d theta.
Yeah.
But then that's not right.
D theta or dt, which is theta. You said it would be theta. Theta's the direction.
Are you saying to use the? No, I know. We're supposed to take the first term.
Yeah.
And respect to theta. Or in the time.
Yes. But theta is a very theta is a function. It'll be hands-on. It's not easy.
Yeah, it takes up and like, it just kind of, like, it's kind of it has this break on this
You're gonna cut it.
Yeah, I'm gonna line it up with like, slides and like that, like website, but then like, send it. It'll break it.
Yeah, so, yeah, data is most probably, I'm just gonna send it. Nothing. I've never done anything wrong.
I oversized my sock, and I just leave it in place. It'll have some thickness where it's just not gonna be.
I would just take it as a reserve. Yeah. Like, fully oversize the sock.
Yeah.
Flip it over and then face it. What?
I need that then.
I mean,
Yeah, if you're facing it, it's stuff on, like, kick comments.
What's all you do?
All I know is the derivative. All I know is the derivative.
With the tabs, right? Planning on cutting off the tabs, but just use the bits.
Okay, so I figured it out after doing some research.
Oh, yeah, don't worry. So you're putting on a little bit of the dribble and then putting on all these and then running the slide through. Basically, if you have multi-spindle,
Yeah.
put lines. Yeah. What are you using high speed? Are you using carbide?
It's still from like part of the carbide.
You get co-op.
I mean, the Dremel, the little like diamond Dremel disc, is like from 30. You just go to like 5 and
Are you, how much do you have to take off?
not actually.
This is gonna take a machine.
You could do some precision stuff.
Just have some I mean, it hit like a team was working out. Because it don't usually work. It would be the good old fashioned reliable.
And so we put the brake rudder in the lid, clamps, like use like the
Four-job?
we like clamp the brake rudder is like internal, so we like wrap it facing outwards, on the outside of the
Okay, yes.
and so we spun it, we put their oscilloscope and like a power supply, so the wheel speed sensor, and just like spun the lid at different speeds to verify that it was like good enough speed. It was flat, I think.
We have to do that. Using the outside of gas for.
We're simulating.
Let's see how close that looks. Yeah.
Alright, so you have to do DRDT, which equals DRD data times d theta dt. So you have to do the derivative in respect to chain rule.
Yeah,
So you
chain
get
rule. Chain rule.
D is that. You just write on the
Like that. How's that? What do we think about this?
because the change in theta is negative, because theta is decreasing, which after expect the velocity vector is negative.
Yeah, so, and here's like, so far, what did we say so far? We said, okay, here's like our derivatives of position B, position A, and one of the gut checks we can do is if the angle, so if this thing is increasing height, is our angle increasing or decreasing? So as we're driving this thing upwards, are we getting a smaller angle or a bigger angle? Smaller. So it should have some, so for a negative theta dot, we should see positive height change. Understand the reasoning there? For cosine? Well, yeah. So there's also the question was like, as theta is increasing, shouldn't cosine will decrease, at least at first, for As theta, sorry, it's back and forth, now noisy.
It's only like a 0 to 90.
Yep. Okay, so it goes 0 to 90. Sine and theta are somewhere either 0 or 1, like somewhere between 0 and 1. And then we have this a negative theta dot. So as that is decreasing, we're increasing the height. So if we have, so it seems to be making sense. We're doing something along the right lines. Cool. So there's two parts that we need to figure out now. How high does this thing need to go? How fast does it need to get there? Or we could also look at like how much it's changed, how much D is changing, because that was really our kind of our first question, right? So how big are these changes that we need to deal with? And how long should it take? When's the last time you changed a tire? Over the summer? How long did it take?
Yeah, for you, probably like last week. But
Last week. Did you use a car jack though? Yeah, no, you use a floor jack, floor pump, right? No?
You just gotta lift the car.
I
It's a
don't
very small
understand.
car.
Oh, a small car. Okay. So for a small car, you can lift it. But if we're using a car jack, what's a reasonable amount of time to lift? Take the thing out of the package, twist the screw, and then get it up to its max height. Like a minute? All right. We could call it a minute.
D of t would equal what? 2d minus 2d minus 2dt.
D. Sorry. Repeat.
D of t would equal 2d minus 2vat.
D of t is 2d minus 2vat.
Yeah. Velocity A.
Velocity A. Well, velocity A is, that one's moving in a circle for velocity A. It's always L theta dot.
Oh, yeah.
Yeah.
Then it'd just be the x component plus
Yep. Oh, just the X component. I see. Yep. Yeah, our screw doesn't really change that J. It's all connected. Like if we move it to the left, we have to move it up or down until it gets to 90 degrees. And then you have like a brief moment where it's not moving up or down. But, okay. So what are these numbers for H, like how high this thing's going, and D, like how far this thing is moving? Actually, this would help because I realized for some reason Husky CT cut out my definition, so L was 20 centimeters. Okay, so L is 20 centimeters.
Oh, cool.
The max height is 20 centimeters.
So H is 20 centimeters, the height that it can reach. 40 centimeters. 40? 1L plus 1L? 40? What about how far hinge A has to move?
Are we
Is it-
including the distance between the 2 hinges?
This one, all we're talking about is distance that A is moving. Because as we turn the screw, both A on both sides is kind of getting closer to each other. Like there's mirror symmetry because of where the screw, how the screw is. Ta-da. So is it 20 or 40 centimeters? 20? All right, 20 centimeters. 20 centimeters. All right, what is that in meters per second? We know how many centimeters, how many minutes, how many meters per second is that?
Well, for the second.
40 centimeters.
So then it'd be 24 meters.
0.2 over 60. 12.
0.2 over 1 over 60. Oh, no, oh, whoopsie. Whoopsie. 0.003. There we go. That makes more sense.
6 bar.
And then another one you multiply that by 2, you get 0.006.
Bar for that is, oh,
7.
you know, I can go for it.
I heard you have to do
Pays half.
Good bird reimbursed, I do, well, it's also good bird reimbursed. I don't know.
Oh. I'm running out of room.
He did it, not me. I infected them, the thing happened, I got it, I could have those first.
It's wrong.
Okay. 007, 003 meters per second. Can we say that both of these have to be constant? Can we specify both of them? Like, can we say that A moves to the left 3 millimeters per second, while B moves at a constant 7 millimeters per second up? Is it a constant relation? And can we specify both at the same time?
It's on a curve, right?
It's on, something's on a curve, yeah.
It's not constant. It doesn't change.
Something's got to change, right? Like we have these intersecting, we're dealing with like circles that are intersecting. So we still have to deal with those sines and cosines. So the question is, which one do we want to set? Or how many things can we set? With a 1 degree of freedom system, how many kinematic constraints can you say that are there? That's a weird way of saying, like, can I specify velocity in multiple locations with 1 degree of freedom?
You want to specify one place and then the sides of everything.
Yeah, so if we say that A moves to the left at 3 millimeters per second, everything else has to obey whatever A does, versus saying that the car is moving up at 7 millimeters per second, now everything has to obey whatever the car is doing. So a little more realistic is that we're driving it at some constant rate. So at least I would think VA is where we'll start there and figure out what everything else does. VB should be like on average 7 millimeters per second, but that'll be the average. And I'm just grabbing our
I feel like somewhere in Massachusetts, Connecticut, Rhode Island.
You for sure in Texas. Someone's a city. No, you got the smile on.
So at least based on the equations that we wrote, we've got 3 terms that we can figure out. How fast A is moving up, which we don't really care about, but then we can figure out how fast B is moving up, which is more the important part. So if I know that this X component is 3 millimeters per second, what is VB? So I have a fixed if I have a fixed rate for X direction, what is my VB? How fast is that one moving? Yeah.
Is it moving at that speed at theta equals 0, or when is it moving at that speed?
So question came up, is this at theta equals 0, or are there different angles that we have to consider? And it's a large angle thing. We can't just say like, it's around 0, because it's going from 90 degrees up to 0. So we have to figure out how it's changing as this thing is moving. Yeah.
So you said that VB is the average?
No, in this case, VB is like the way that it's written here, VB is the actual 2L theta dot sine theta. If we took the average value, if we took all the calculations of VB from theta equals 90 until we get to 0 when it's vertical, if we add all those up, divide by the number of velocities we calculated, it'll probably be about what we found, that it was h over that delta time, the total h. That's what, at least it should be. That's what I think. Question? Or just pondering? So part of this is that there's got to be some angle dependence, right? Where we're going to end up with a function, even when we say VA is moving at a constant speed, VB is not constant. So what is that function that we're going to get out of it? What do we think? How do you get there? Oh, you want Diffie Qs? Some Diffie Qs? Okay, give it a shot. See what happens. Think differential equations? I always like
That was a cobblestone. 20. Let's just put it in terms of variables.
Because in my mind, like VA changes as VB changes. Like
Yes.
they change go hand in hand. So my main thing is how can you set one equal to a constant if they're both changing interchangeably?
So if we're driving the screw at a constant rate, the screw's going to move at that rate of 3 millimeters per second.
Yep.
And everything else has to do whatever it needs to keep up with that.
So it's actually more so,
He's saying,
Alright,
I could, is equals 0.003.
because if you're spending at constant
Screw
revolution,
itself is moving.
VA is gonna move at constant revolution, but then,
It's also moving up.
so it's not like you're putting a certain amount of, it's not like VA is that, when you gave us VA, it wasn't VA at a time, or at time equals 0, it was just VA equals this.
Yeah.
So VA is a constant.
Yeah.
Okay.
What does this give us? Yeah, we're just saying we're gonna turn the screw so that it's always moving
Other half.
at this constant.
And what is
Okay.
the velocity of the platform all the way to the top.
I thought VA was just the initial velocity, so it's actually the velocity. After changing the threshold, it's actually just the velocity.
Because
I think
it depends on how you find the coordinate system, but if you consider I going to the right, as you're screwing in, it's going to the left and raising it.
But if you say that no matter what, this screw is gonna move to the left, the whole, the rest of the system will be whatever it needs to keep up with that. So that one's.
Wait, this is, that's cool.
Yeah, exactly. Yeah.
For constants. No,
Yeah, kind of like the end of
This is dy dt. So then you just send dt over there.
Yeah.
Yeah, you are. Genius.
Not really, no.
They call me
It is
the
right.
way I'm first in
That's probably.
Does that mean that's
There's a lot of that. Race language. There's a lot of
All right. What do we think? It is Friday afternoon. It's hard to think. It's okay if the answer is like, I can't think. But any thoughts on how to connect these? So one clarifying question that came up was, like, I don't understand, like, isn't VA depend on the motion of VB? Which is true, like, this is all connected. If one part moves, the rest of it has to keep up to move with it. Otherwise it's broken. And we're trying to design it so that it does not break. So when I said, like, hey, this X component of VA has to move at this constant rate, really I'm just saying, I'm setting that one degree of freedom. I'm choosing one and saying this one has to be true. The rest of you all do whatever you need to do to keep up with this motion. So the screw is gonna move at that 3 millimeters per second. The rest of the system has to, like, bend and flip and move so that it keeps up with that screw motion. Just, I don't know if you were, like, in your head visualizing, like, yes, as the screw turns, it'll all keep up and it all makes sense. Or maybe it's like, it's Friday afternoon, I got 3 more minutes, and I'm out, 50 degrees tomorrow. Should be nice out this weekend. Even today is pretty nice. This is we made some good progress. Should we call it?
What's the question?
The question mark? I want to know, what is it? Yeah? You want to finish it? Yeah, I'm fine with that. Yeah, so how do I get this into that question mark? How do I connect the fact that screw moves left, thing moves up? How are they connected? That's what we're trying to figure out.
It's a function of in terms of your time, and then I just plug in.
Okay. Make a function of theta. All right, so it is Friday afternoon. Let me show you at least how I approach it, and then we'll come back. I'll erase it, then we can start there on Monday. Do we have 2:30? We have 5 minutes left of the class. We have 0? We have 0. No, it's over, it's over. I'm okay just saying, let's call it, and then we have 5 minutes. I'm not leaving. So anyone who wants to stay, you're welcome to, but also like enjoy the day. It's way too nice out. So let's call it. We'll be back on Monday. Sound good? All right.